Good Tuesday to everybody in COM 702. Welcome to boom, week 8. I'm looking for my coffee cup because, it's that time again. Mm, week 8. Everybody, hold on. You're just a few days away from Modular Week, in which you get to take a little bit of a break. So stay motivated and stay caffeinated. What do we have here today? Shortwave coffee, one of my favorite coffee hangouts in the little town that I live in, and that's why I have their cup. Okay, enough about me. Hi everyone, how you doing? You doing okay? Um, and besides the labs, how goes the semester paper, the term paper? Is that coming along? Some of you have emailed me, noting that, well, can I change my topic and can I do this? And okay, fine, but we're now at the beginning of March. Today is March 1st. The papers are due in April 23rd to be specific. So you should be settled not only on your topic, but you should be well underway in the research for said topic. I mean, remember, the perhaps the most laborious and just in terms of hours and slogging through process for you is the literature review, and you can't do a literature review for a topic that you haven't settled on. All right, so this is what I want you to do. If you have not settled on a topic, I want you to email me, please. If you're having problems, if you're stuck, if you don't quite know how to sort of wrap your head around what and how to do, email me, and we've got to get you straightened out and get you going. This is how I find approaching a topic to be helpful. Number one, first, I think of a big question, something that interests me. All right, big picture question. And then I formulate a hypothesis about that question that looks at some part of that question. And remember that a hypothesis has three components, and this is not only important for a proper hypothesis, but this is a great benefit to you. All right. So number one, it has at least two variables. Right, bare minimum. Can have more, but at least two. Number two, you're making a prediction about the relationship between those two variables. And number three, that prediction has a direction. It's going, from one variable to this one, not from this one to this one. Okay. Why is that a benefit to you? Aha. Three things. Number one, as soon as you have a hypothesis, now you have a focus. Look, for big questions, and there might be a lot that you're interested in, that's great. Fantastic. You can write many, many articles, many books within the course of your life, but within the course of this semester, the deadline for the paper being April 23rd, you are not going to write many articles and you are not going to write many books. It's okay to focus on just a small slice of a bigger picture. All right. And so getting a well-written hypothesis helps you do that. Number two, getting a well-written hypothesis will inform you about what it is you got to run down for your literature review. All right. So if you're hypothesizing about, say, I don't know, just pick anything. Let's say, the size of print in quantitative research texts is positively correlated with a decline in readership. I mean, there may be other factors where quantitative research texts are concerned that are positively correlated to a decline in readership, like that they're quantitative research text. But we don't have anybody like that around here. Okay. All right. Now you know that in your literature review, you've got to discuss something about the nature and the history of print in textbooks. Why? What has it been? Why is it this way now? Is the quantitative research text you're working with just an outlier, or is this part of the trend? Is this the industry saving money? Is it that people that do quantitative research tend to be short-sighted? Anyway, there's a pun in there. And so they're always, like staring into a book like this. What? That's part of your literature review. And then, you get to cover um, who's in quantitative research courses. Is it requisite, or is it only for people in specialized fields? So why else might they eschew the text? Is there abundance of resources on the internet and they don't buy the bloody text in the first place? Because why would you do that if you could watch an Andy Field video? Oh, no, okay. This helps you focus to construct your literature review. That's the second thing. But number third and most important, okay, having a good, strong hypothesis is going to tell you it'll guide you, I should say, how to construct your survey instrument, because it's going to guide you to and through constructing questions to gather the type of data that you need to test the hypothesis. So, for instance, if you have a hypothesis in which you say, there's no difference between men and women in the average amount of time that they use social media to strengthen their faith, right? Because I'm lab number 2, so you're familiar with this. Okay. All right. What do you need to run that t-test? Well, you need a question that a categorical, a question to generate categorical data that counts male and female. Now you need a question that generates continuous data about, how often do you use social media to strengthen your faith? So when you can run the two, you can run the t-test, and then you can compare them. So having this sorted out in your hypothesis is going to tell you what sort of questions that you need to create to generate the data that you need. Keep in mind, we say categorical data, we say continuous data. We talk about this data like it's like apples and pears or something. I'm just using fruit because I'm hungry. All right. And you go, well, you can't make an apple into a pear and a pear into an apple. But that's not exactly how data works, because you can frame a question to generate categorical data, or you could frame a question about the same thing to generate continuous data. It's up to you as the researcher, as the designer of the survey. All right. And having a strong hypothesis, a clear hypothesis, make sure your hypothesis isn't asking multiple things. And, if you want to ask multiple things, if you want to ask relationships about multiple variables, then get more than one hypothesis. That's fine. So having that nice and clear will give you focus, will help you in constructing your literature review, and it's going to help you build the survey to generate the data that you need to run through SPSS to answer the hypothesis. You see, it's the circle of quantitative research life. You see how that goes? I think, if someone that's dressed like Mickey Mouse comes crashing through my door, you'll know that Disney has finally gotten sick and tired of me of ripping them off, and they're serving me with a copyright infringement suit. All right, let's take a look at the questions from week number 7. This is all about definitions and helping you read and understand regression analysis. So some terms and some things here. Question number 1. What different kind of information do R and R squared provide in a correlation analysis? Does correlation show causation? Is it used to predict? All right, there's sort of a redundancy in that question, but it's important that you understand. Okay. All right, Amanda, I like what you're up to here. R and R squared provide information about the linear relationship between two variables. Okay, so this is most of the time what we're about as quantitative researchers. We want to know how the one thing, like say this coffee cup, relates to the other. Say like this, the coffee used to be in there, but I just finished it. All right, we're looking for relationships between events and emotions, images and actions. We're looking for relationships, causal relationships. All right, we're going to get to correlation causation here in just a second. Okay, but anyway. Predictive information about linear relationships between two variables. R is the Pearson correlation coefficient, excuse me, which measures the strength of a linear relationship between two variables. In other words, is there a relationship between these two things? Anything, okay? R squared is the coefficient of determination, which measures the proportion of variance in one variable that is predicted from the other variable. In other words, how much of what happens here is being driven by this here. So how much of it happened in the dependent variable can we say is being driven by the independent variable? R and R squared values range from -1 to +1, with a value of +1 indicating perfect linear relationship, -1 indicating perfect negative linear relationship, meaning no relationship at all. Good answer, Amanda. Okay. Second part, and this is, don't get tripped up on this if you see it on an exam. A wink. Correlation does not show causation. Correct. This probably, if I had to rank mistakes that people make in evaluating cause and effect in the world that they live in. Because remember, as communication scholars, we're all about what's the message, what's it shaped, where did it come from, and then more importantly, what does it do, did, will do. That's our business. All right. And you will, if you start looking for this, you will notice this a lot, that people, and this isn't without reason, but people mistakenly assume because two things are happening at the same time or in proximity to each other, that the one is causing the other. Now, it might be, I'm not saying that it's not, but two things happening, that is correlation, does not mean that the one is causing the other. So Amanda writes, it simply shows the degree to which one variables are associated. In addition, a researcher should not use correlation to predict. However, correlation can identify potential relationships researchers can explore further. Excellent answer. And a classic example, I think I gave you this once already, is this rock. I got this rock from the slopes of Kilimanjaro on the Tanzanian side. Okay. And besides being igneous, this is a magical rock, because whenever I go out into the town that I live in and I slip this rock into my pocket, there are no tigers that no tigers come near me. I have a tiger-free day when I carry this rock. You might be saying, come on. That's exactly my point. Because I'm carrying a rock and I don't see a tiger, okay, those two things are happening simultaneously, does not mean carrying the rock is keeping away the tigers. Okay, correlation, causation. So because there's a linear relationship, carrying the rock, tiger, or maybe, I could test it. I could run a survey that said, well, how many tigers do I see in the middle of Missouri, and on days that I carry a rock and days that I don't carry a rock, and if there was any relationship, which would be weird, that doesn't necessarily mean causation. Okay. So watch out for that, and watch that. Start looking, in news stories and listening to people's op-eds and opinions, people that you work with, and you'll see what I mean. You will see what we mean when we say that one of the most common mistakes in evaluating cause and effect is confusing correlation with causation. All right, question number 2. Explain the difference between simple regression and multiple regression. Explain why regression is used. Give an example. I think, I forgot to attach a name to this answer. My very bad. Let's just go quickly back to Blackboard here. I don't know who this is. Well, whoever it is, if you recognize your answer, very well done. I think this might be you, Tim. Field says that regression analysis is a way to predict outcome variables. Okay, simple regression. Okay, in other words, regression is how much of the result of this thing is being caused by this thing, and the result of this thing is the dependent variable. The causal thing is the independent variable. So that's what we're doing with regression. Now we're also looking for direction, okay, and we're looking for proportion. How much of what happens here is caused by this? That's back to R and R squared. Okay. In simple regression, there's only one predictor variable that is used to explain the variation in the dependent variable. Okay, yeah, I like how you're mixing, British and American terms. So there's only one independent variable that's used to explain variation in the dependent variable. For example, if we wanted to predict the attendance at Disney theme park, I think this is yours, Tim. If I'm identifying the wrong person, let me know. Disney theme park, on the weather, we could use simple regression to model the relationship between attendance and temperature. Here, temperature would be the independent variable and attendance would be the dependent variable. Okay, perfect. On the other hand, multiple regression is really, as the name supply. There are two or more predictor variables that are used to the variance of the dependent variable. For example, if we wanted to predict the attendance at Disney theme park based on multiple factors such as weather, marketing, number of rides, wokeness of the company. Oh, I'm sorry, that was mine. I threw that in. We could use multiple regression to model the relationship between attendance and these independent variables. Excellent answer. And in life and human behavior, it is rarely the cause that there is a single independent variable. Now, sometimes in statistics, it's useful to break those out and say, let's just look at this thing, okay? But in terms of, causality in life, there's usually multiple things. Okay. Question number 3. What different kind of information do the following outputs values provide in a regression analysis? Okay. And then we get a whole bunch. We get F, mean squared, standard error of estimate, B, standard error, and beta R squared, and adjusted R squared. Okay, so these are the values that you're seeing, and you will see when you get that printout from SPSS. And so it's important for you to know what the blazes they are and why should you care. Okay, so let me see. Timothy, I think, you did a good job here. F in regression analysis, F value checks to see if the means of the two populations are. Now, here's something, I'm not picking on you, Timothy, but this is something that I see a lot in your answers, are significantly different. Not just significantly different. Are they statistically significantly different? Okay, because I don't like just significantly, because that doesn't, within the context of what we're doing, that doesn't tell me a lot. Okay, is there a statistically significant difference? And you go, okay, well, statistically doesn't tell me that. Well, what's your tolerance level? Is it 67, 68? Is it 95? Is it 97? Okay. Anyhow, mean squared shows the average sum of squares, eliminating a relational bias from different mean sums within the data set. B, here we go. The B value represents the under standardized beta and represents the slope of the lines between the predictor variable and the dependent variable. When you have like the bell curve between the two of them. Standard error of estimate and standard error of estimate test the accuracy of the prediction made in a regression model. Right. So when you say this causes this, well, how accurate are you? Standard area of error. I don't know why I can't say that tonight. Excuse me. A beta. This will show the standard deviation of the sample data set. It correlates the difference between the sample data set and the population data set beta information. Okay. Yep. R squared, and you know this one already because you answered it like back in question number 1. This will indicate the variance of dependent variable based on the independent variable. Okay. So variance of dependent, meaning how much of what's going on here is being caused by this over here. Adjusted R squared, this element will aim to show whether adding additional predictors to the model will have a significant impact. Because again, back to what we were just saying, it is rarely, just a single cause and a single outcome. I mean, even something as straightforward as he punched him in the face, and then he, the person who received the punch, became angry. Okay, well, all right. So you go, oh, well, what are variants? You know, what other variables might there have been besides the punch in the face? Because that could be pretty responsible for the dependent variable. He became angry. Well, maybe he called him a nasty name as he punched him in the face. Maybe when he punched him in the face, he fell down and he broke his phone. Okay, so other variables that might enter into the equation, and that's a weird scenario. I don't know where that's coming from. It's been somewhat of a long day for me. Okay, but you get the picture. I hope. Okay. Question number 4: what does variance partitioning mean, and how is it accomplished? What is the relationship between predicted variance and error variance, and why are they important? Okay, this one was a tough one for a lot of you. I could, reading through your answers, you're trying chewing on it. Okay, Amanda, I think you did a good job putting your finger on this and putting and by the way, when you write these answers up, for your own sake, if not the sake of your classmates, try to translate quantitative research speak into plain English. It's not that we don't use proper terminology, but if you can explain it in a way that's just straightforward, if you can translate it out, if you will, into just straightforward language, this will increase the likelihood and your capacity for understanding the concept. So when I'm reading through your answers, I'm looking for that. I'm not looking for have you just quoted from Andy Field, or you pull, and a lot of this isn't necessarily a criticism what I'm about to say, it's an observation. A lot of you just pull straight off the internet. How do I know this? Because, well, I've been teaching this class for a while, and then number 2, I just it just has a certain sound to my tuned ear. Okay, don't do that to yourself. Try to translate this into just straightforward English so it makes sense. All right. I know you're getting a lot thrown at you this semester, but that's really important. Okay, back to Amanda. Variance partitioning is the process of separating the total variance of a given phenomenon into its constituent parts. Okay, can you simplify that for us, Amanda? Variance partitioning allows researchers and analysts, okay, to understand the relative contribution of different sources of variance. Okay, so again, how could you bust that down? Well, say, there's a variation in the outcome, the dependent variable, the outcome variable. What's causing it? Is it a one thing, or is it a number of things? And if it's a number of things, how do you partition the number of things? Okay. It is accomplished by calculating the variance of each source of variance, then summing the results. The relationship between predicted variance and error variance is that the total variance of a given phenomenon equals the sum of its predictor variance and its error variance. All right, that's, that makes sense. Predictor variance explains error variance as the variance that the model does not explain. Okay, both are important because they provide insight into how well the model fits the data and how accurate the predictions are made by the model. Okay, does everybody understand that? Because looking through your answers, I could see that you're getting the jargon right, which is good, but I couldn't tell from some of your answers that you understood this. In fact, I think, Timothy, you start off by saying, I think you went first. You started by saying, I had to work at wrapping my head around this. Okay, so look for videos that explain this. I mean, even try something like type into Google, put the term in, and then say, define variance partitioning in plain language or in plain English, and root around until you find something that linguistically makes sense. All right. I'm not saying that you're getting it wrong. I'm just saying that looking at some of your answers, I wonder, right? And I want you to get it right. Okay. All right, everybody. Thank you so much for all your hard work. And if you, again, sort of loop back to where we started, if you haven't started on your paper, if you haven't settled on your research topic yet, please contact me. Let's get that going. You've got just a half of the semester left. Okay. And how and who and what speed at which someone responds, somebody's respond to your survey is not, I mean, unless you're going to track people down on the street and say, hey, take this, which you're probably not. You want to leave yourself time to get data that you can analyze, because if you don't have it, then you're in a bit of a bind. Okay. All right, everybody. Thank you so very, very much for all your hard work. Again, reach out to me if you need any help, and I will see you on Blackboard. Take care. God bless. Bye-bye.